Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. How's it going, everyone? This is Joe Fairley from Ascent Fabrication, owner, certified prosthetist, and 3D printing enthusiast. You are listening to the Fabrication Friday podcast. Thank you very much for tuning in this week. You've just got me this week. We're going to have a little bit more of a low-key podcast this week. We're actually recording on Sunday this week. This week kind of just started to get away from me with a lot of really cool projects going on at Ascent Fab. Some things in prosthetics and orthotics, obviously, but we're also starting to get into a lot more outside the field of prosthetics and orthotics. So, getting into kind of any contract manufacturing that we can really get into, little one-off projects here or there with locals here in Saratoga Springs, New York, or other businesses around the country. So, with all those different things that Ascent Fab does, today I wanted to focus on kind of giving you an overview of who we are at Ascent Fab. What are some things that we're working on? What are some things that we've been developing over the past 2 years? Really just giving you kind of a roadmap of where Ascent Fab is going in general. So I did want to start with the print of the week actually here. So the print of the week is a carbon fiber polypropylene below knee prosthetic socket. So this carbon fiber polypropylene prosthetic socket, that's a mouthful, with a foam flex air flexible inner socket. So the carbon fiber polypropylene is from PP Print. As some of you might know, we have a very good relationship with PP Print, bringing in their polypropylene filaments from Germany, and we have all their different colors available, as well as their new Pro Surface. They have great surface solutions for completely minimizing warping as much as we possibly can on the print bed. They really have some nice solutions for some turnkey and easy polypropylene printing. So we have their full solution here at Ascent Fab. If you haven't checked out our shop page yet at ascentfab.com/shop, please check that out. There are a few new items in there. This carbon fiber polypropylene from PB Print being one of them. So we have it in 2.85 as well as 1.75 diameter filament, currently only in 600 gram spools, but we are looking to get some larger spools in the 1.8 kilogram range. So at the 600 gram level here, you can get about one below knee prosthetic socket. So this socket was 502 grams, printed in 2 hours and 16 minutes on the Filament Innovations Kratos. Absolutely love their machines. Can't really say anything bad about them. They're really built to last, and really dependable in terms of the print quality that's coming out every time. They put some really high-end componentry on there. They have some of the best support in the industry. So reach out to Mike Gorski if you're looking to really up your game on the FDM 3D printing side. So the Foam Flex Air Flexible Inner Socket was printed in 12 hours and 50 minutes and only weighed 234 grams. So at 736 grams, I won't do that conversion right now to pounds, but I mean, is that 1 pound and a little bit? Extremely light prosthetic socket. That is a lot of great feedback that we're getting from these polypropylene prosthetic sockets that we have been putting out there so far. Very lightweight. The patients like that they're lightweight and very durable. We have had these on patients for over a year now. So on a little over 10 patients, I'd say, across the US. from coming from Ascent Fab personally, and then from our other training sites that we've actually gone into clinics and trained their prosthetists, orthotists how to print this material. There's a whole number of other patients that have been fit with these sockets that we haven't been able to track quite exactly. So, but we do know that there's over 10 patients, most of whom have been walking on them for more than a year now, and no signs of real degradation. We will say with the polypropylene, it is a good idea to anneal your prints after printing. We tend to do a spot annealing. So we actually take a torch and torch flame and go over the very high areas of concentrated force that we know are going to be subject to the highest forces from someone walking on it. So we'll actually go through and blend the layers in those areas with the torch, just getting it to the point where it kind of looks wet. The filament looks wet, but the plastic isn't yet deforming. It's a very fine line there that you really need to watch, but definitely very crucial for having these very high-end, FDM prints come out from these machines. So this carbon fiber polypropylene is extremely stiff, very stiff. I haven't seen a polypropylene, partial polypropylene print be this stiff yet. So that's really nice to see that contrast and difference between the polypropylene that we've been using, just strictly polypro, and then now this carbon fiber polypropylene being very stiff. The typical polypro is a little bit flexible. So, still very nice for a preparatory socket stage for those patients that could need that. But otherwise, we're kind of just going for it and putting it out there as this carbon fiber polypropylene could make a definitive FDM 3D printed prosthetic socket. There, I've said it. It's going to happen. That this socket will be tested clinically, as well as we're going to kind of look around for some people to help us out, do some cyclic testing. We know the AOPA socket work group is working on some cyclic testing. So I'm going to reach out to them and see if they want to start testing some 3D prints that we're doing. We have tested just the typical polypropylene to over 1 million cycles or over a year of someone walking on it. And the for our ankle foot orthoses, I should specify, not the prosthetic sockets per se, but the same polypropylene in solid ankle and articulated AFOs. They lasted more than 1 million cycles. We've seen the same thing clinically from these prosthetic sockets being out there for more than a year. So we're very, very fortunate and very, we're liking this material for that more definitive use. So really can now say that material is very well suited for long-term use of up to a year for the polypropylene at least. And like I said, we might look at this carbon fiber polypro as being the first actual FDM printed definitive prosthetic socket. So we're also looking into if we're talking about the L coating side of things, we would suggest using the ultralight materials L coat. I think I've gone into this before, but basically the ultralight materials, when you look at the chemical composition of polypropylene or PA11 nylon, if we're going HPMJF, when you're comparing it to strict carbon fiber, actually polypropylene and PA11 nylon have a lower density than carbon fiber. So pound for pound, same volume, polypro and PA11 have less mass than carbon fiber does. So ultralight materials code, carbon fiber, titanium, or equal, I would highly suggest to use that code for these prosthetic sockets. In terms of the acrylic code, we're looking at doing a definitive FDM carbon fiber polypropylene prosthetic socket. We have been testing out some spray on acrylic, which is tending to work quite well on this specific carbon fiber polypro blend. Really adheres well to the plastic. It's very scratch resistant too. makes the layers a little bit more smooth, which is pretty interesting too. Could be spraying the inside and outside of the socket over a few coats, and we've seen that it's helping even more so with the rigidity, and allowing a little bit more of a smooth interface. So be that for what it is, acrylic, getting the acrylic code. In some states, that's an extra $300. In some states, it's an extra $600 of reimbursement. And up until now, we haven't been able to really code that for definitive 3D printed prosthetic sockets until now. So reach out to us at Ascent Fab to see how we're going about this definitive prosthetic socket FDM 3D printed with carbon fiber polypropylene and adding in acrylic. Stiff, lightweight. Should mention, you've seen in the picture here, this carbon fiber polypro socket. You do notice some reinforcement pillars on the distal end. That is very specific for two reasons. The first reason is for support material when this object is actually printing, because we're printing in vase mode. Vase mode where you're only going in one continuous travel path the entire way up the socket. So with that, you can't print support material unless you went from printing non-vase mode up to vase mode at that point. Just for a general, strength, integrity, and consistent wall thickness, we tend to like these reinforcement pillars at the distal end. We've seen that they do make the socket stronger if they go all the way from the bottom of the socket up to past wherever that component ends. So in this particular instance, this was a Bulldog 3 Gen A lock, typical prosthetic locking mechanism that's on the market. The reinforcement pillars just not only help that print while it's printing as support material, but it's also reinforcement structurally, increasing the surface area all around the distal end so that it can withstand higher forces of impact. So that is our print of the week, the carbon fiber polypropylene, now available here at Ascent Fab. So getting into a little bit more a kind of overview of how Ascent Fab has evolved over the past 2 years. So we have been very involved with the prosthetics and orthotics industry. Obviously, I'm a certified prosthetist and board eligible in orthotics myself. And I was seeing patients before I started Ascent Fab. And in one of the previous episodes, I kind of went through my whole journey into this. But so we have been very, very heavily involved in that field, simply because a lot of 3D printing is happening in our field now. I don't really think it's useful to kind of throw out estimates of percentages of numbers of who's using it, who's not using it, but a very high general trend exponentially of clinicians are using 3D printing in their practice on a day-to-day basis now. So, if you are still somewhat on the fence about how you can get involved with 3D printing, now's the time. There's really no excuse. There are a number of very easy to use 3D scanners, low-end 3D scanners in the market. Comb being and I say low end, that meaning easy to use, low barrier to entry in terms of the finance side of things, and just not a steep learning curve whatsoever. It works on an iPhone 10 or newer, on a couple of the different iPads as well. Look into Comb seriously before looking into a different 3D scanner for your clinical practice. If you're moving from the structure sensor, a lot of people have those, or from a different scanner, you're just looking for different options. Definitely check out Comb. Comb is very, very helpful getting started. They'll get you up to date with a 10-day trial on how to use their app, which is using the front-facing camera of one of those iPhones. No Androids yet, but using that technology on the front-facing camera, that kind of facial recognition. They have a lot of other algorithms in the background as well to help with the tracking and the accuracy, which is in 1 to 2 millimeters of accuracy in most cases. And their app is different than all those other apps that are on the market because of these different algorithms in the background. And they've specifically designed this to be useful for the prosthetics and orthotics field, where 1 to 2 millimeters of accuracy is exactly what we're looking for in most cases. So check out Comb. Again, getting started in this industry is very easy. There are some very low-end 3D printers that are now available that are very useful. We sell one, the Artillery Sidewinder X2 at $300. $300, very low expense to just get started in 3D printing, right? Start dabbling with it. We can obviously help you here at Ascent Fab. This whole month of July, we were offering a promotion to, if you booked an in-house training with us, that you would receive one of these Artillery Sidewinder X2 3D printers with the training. We actually had up to 3 people actually take us up on that offer. So 3 trainings we booked within the last month. We're going to be pretty busy here over the late summer into early fall, going out to these clinics, training sites to get them up to speed on how they want to use a 3D printer in their clinical practice. Now, everyone is a little bit different. You really have to look at the reasons why you want to 3D print something in your practice. But there's a lot of reasons to 3D print things in our practice now. So we can definitely help you out with the training side of things. The training, what all that entails is I would come out to your training site for 2 days. We run through the entire gambit of how to go from 3D scan to digital clinical modifications to actually creating that negative shape in another software, to the slicing side of things, and then to printing and fitting a patient. So we'll run you through the entire list of how we actually go from capturing that image to fitting a patient within those 2 days. And then obviously it's an ongoing experience for us, because there's going to be things that we help you continue to iterate on as you move forward in your 3D printing experience. So we will support you month to month on a monthly plan to actually help not only the troubleshooting as you initially get started, still learning the digital design that we'll teach you within Autodesk Mesh Mixer, another free software. A lot of the slicer programs are free that we use as well. So again, the barrier to entry in getting into 3D printing is very, very low, folks. Really no excuse to not get into it now, even if you're using it for just test sockets. Really very easy. So let's go through a list of kind of what Ascent Fab is printing, starting out with the prosthetics and orthotics field. So we are printing, we've got prosthetic test sockets in PETG. We have flexible inner sockets in a ProFlex similar material, TPU, thermoplastic polyurethane. We have 2 different styles of TPU that we typically use, just that typical ProFlex similar material. And then there's also ColorFab's VarioShore. VarioShore is very interesting for our FoamFlex Air and FoamFlex designs, where the chemical in the TPU actually allows the material to foam as it prints. That's not to say that it doesn't stop being TPU. It's still thermoplastic polyurethane through and through. However, it lightweights that part. Because of that foaming, you don't actually use as much material during the print. We haven't done any actual distinctions on how much material is saved from a TPU prosthetic socket to a VarioShore prosthetic socket. However, looking at the weight, similarities, I'd say it's about half the amount of material that you're using. So really interesting materials there for flexible inner sockets. Obviously now we're doing, preparatory sockets with polypropylene. Again, definitive FDM 3D printed. You heard it here first at Ascent Fab. Carbon fiber polypropylene prosthetic sockets. On the more definitive side as well, you could go more industrially 3D printed at HP multi-jet fusion or selective laser sintering. SLS with PA11 nylon specifically. PA11 nylon has some other higher elastic properties than PA12 nylon, so that's why we like PA11. So that's on the more industrially 3D printed definitive prosthetic socket side. We also provide that as a service through a couple third-party partners. It's an interesting form of 3D printing that is definitely useful in our field. However, the price point for it right now, without volume, if you're just going to one of these manufacturers one-off, is not worth it at all. You're going to be paying 800 upwards to 1,000 or more dollars for a typical BK prosthetic socket. But however, you work with us on this more high volume aspect, the more volume we have, the better we can keep our prices. Right now, we have some of the lowest definitive prosthetic socket prices on the market, if not the lowest, through multi-jet fusion and selective laser sintering, and even more so now with the carbon fiber polypropylene, because that is a third of the cost of a multi-jet fusion socket. So, really want to look into that when you are thinking about what kind of definitive style sockets you're looking to provide patients. So we've got all the sockets covered. We do a fair amount of componentry as well, actually, getting a little bit more into that. Just kind of typical 4-hole pattern style componentry, whether it's just a drop-in 4-hole component with barrel nuts made out of TPU, or we have our suction cushion that could have a one-way valve that's integrated within that socket, and the 4-hole distal componentry coming up. We have a lanyard lock as well. Again, all of these are very, very available. If you go on our website and look for the work order link at the top of the page, that's where you would order all these components. So getting into a little bit more componentry. Now also our protective covers are getting to be a lot more elaborate and well established. So our typical prosthetic cover, it was the print of the week a couple weeks ago, and it was a outer shape of a patient's contralateral limb. So typically we ask for a 3D scan of the contralateral limb and then a scan of the prosthetic itself, typically with comb. Again, we're getting the best results with comb. So we'll do an outer TPU cover that is about 2.5 millimeters in thickness, has a posterior slit that incorporates an inner cover, which it mates with, and a magnetic closure. So easy on, easy off over your prosthetic componentry. And your patients could put it on or off themselves. In some cases, you may not want your patients to take it off. However, we can work with you to make something, more not removable if you're really looking for something like that. But just from our experience working with other covers, having something removable is a lot easier to deal with than not. So our typical protective covers, we also have specific prosthetic knee covers. So the Proteor Quattro knee, that is one of the newest knees that we have a specific cover made for. So the Q cover comes in a number of different colors: black, blue, red, green, and there's 3 skin tones of that foam material as well. And that only covers the knee itself. So, if you're looking to just protect the knee, you don't really want any other anatomical shape, that covers for you. There's also a charging port, little flap in the back to cover up the charging port. Then we have the Q anatomical cover. The Q anatomical cover is a full-length prosthetic cover that goes over the quattro knee, and then mixing in a scan of the contralateral limb, you can have that cover go all the way down to the top of the foot shelf. That also has a posterior slit and we're working on a couple different closure systems for that one as well. The magnets kind of protrude in areas where we don't quite want them, so we've installed kind of these latches now in a couple instances, and those are working a little bit better. So still easy on, easy off access if you want that. Again, we can always design it to be a little bit different if you have a specific reason for it. But that is our typical Q anatomical cover. And again, those could be in the VarioShore material, foam material itself, or we could actually do those in TPU. So TPU, the ProFlex similar material, that's typically what we do. Again, the regular protective covers out of. It works really well for the Q anatomical cover as well. But we can do those in the 3 skin tones of the more foam type material VarioShore. So you have those different options when we're looking at colors and materials to work with. The TPU also comes in a light skin tone and a dark skin tone. So you have those couple options as well as just black. If you have a fun, different color that you're looking for, we can definitely look into getting you a different color, potentially in TPU if we can find it out there in that 3D printing filament. So, if you have some specific, requests, we can look out there and see what's available. We do a little bit of design aspects on those as well, for a little extra charge, for any kind of artistic component that you want to have on the outside of the cover. Typically we emboss it. We don't actually have holes going all the way through the cover because one, the cover is supposed to protect the prosthesis anyways. So, we don't think there should be really holes in the cover. And, it's just easier to print, honestly. Less support material, easier to print. So just embossed. So that is a lot of the, typical prosthetic devices that when people are coming to me looking to get into 3D printing, those are some of the few first things we get into. Starting to get into some other prosthetic devices, we also have our silicone tailored liner. It is a custom prosthetic liner, a cushion liner for now, working on a locking liner as well. Typically comes in our Ascent Fab blue color. However, we can do any color of a palette for this silicone. So, these are really nice because we have specific targeted cushioned buildup areas, similar to our Foam Flex Air design as well. So, the custom prosthetic liner. We're also looking into a lot of other, 3D printing, silicone specifically, 3D printing molds for other silicone purposes. So there's a couple different ways that we go about doing these custom liners. With the orthotic side of things too. So getting more into ankle foot orthoses, we've done a number of ankle foot orthoses now, solid ankle and articulated, super malleolar orthoses. Most of this is all, again, FDM 3D printed. Now, we can go the more smooth looking route and have the vapor smooth multi-jet fusion or selective laser sinter devices. However, again, they're going to be another 50% price increase or even more than that in most cases. And that's dependent upon the size of the object, really. So in orthotics, it's a little bit more tricky to have consistent pricing across the board because of just the variance in different sizes of these devices. So we have done multi-jet fusion and selective laser sintered ankle foot orthoses, and they come out beautifully. Honestly, if you're looking for 3D printed devices for that purpose, and you don't like, for whatever reason, the layered look of FDM printed devices, then there's that option for you, and you can pay a little bit more to have that option. We haven't seen any, again, real degradation and structural integrity failures from our foot orthotics, our super malleolar orthoses, and our ankle foot orthoses, to really say that they are that much lower end than a multi-jet fusion or selective laser sintered part. Having the aspects of design that we implement into it, having variable thickness in certain areas, having an appropriate thickness, making sure the part is annealed afterwards. Those things are more important than strictly, having the layers actually look into the print. Personally, the layers don't really bother me. If I was seeing orthotic patients right now, I would also be providing these devices to patients, again, simply because of the cost. When you're printing in-house, the cost of those devices is drastically reduced. So again, if you're looking to utilize 3D printing, getting with us as a central fabricator, being able to print you a few devices to understand how to use these devices in practice, it's a great way to start. But then when you're really looking to take advantage of 3D printing, that's when you have printers in your office and you're learning how to do some of this design work yourself, and you're actually implementing it, on your own. That is definitely the biggest advantage of 3D printing is, being able to reproduce parts for a low cost because of some lower material costs, high availability of those materials right now, and the lower labor costs of actually fabricating those devices. So, it's great to work with us as a central fabricator if you don't have the space or the time. Even if you're a single clinician, we've got a clinician that we've been working with for over the past 6 months, that is a single clinician in his own practice, and we've been supporting him from time to time with some of these devices, and he's been learning about 3D printing. Now gotten a little bit more interested in some 3D printed devices that he wants to implement a little bit more, and he's starting to have us start to teach him more of how he can implement that on his own in this practice. So that's kind of where we really see Ascent Fab having a big impact in that particular field, is working with us to either work for central fabrication. We obviously take in 3D scans from all over the country, Canada, Costa Rica, working with people in Mexico and Haiti and Africa, in order to take that 3D scan data and create devices, print them out, ship them out to you. That's obviously our kind of day-to-day operations. The training side of things, that's again where Ascent Fab is kind of expanding into more training and different types of training. I've mentioned Mesh Mixer as our master class that is still in development. I was kind of putting it out there as a feeler earlier on this year to see how much interest there would be in some recorded videos of how we design these devices in Mesh Mixer to be readily available there on our website for download. And you can download the entire Mesh Mixer masterclass series, or just individual modules based off of what devices you think you want to learn to design. So we're moving forward with that. We are starting to put together these modules, and that will be available probably before the end of the fall. So working on trying to get those up to date so that there are those resources when you want to go to just a strict video. Maybe you don't have that financial side of things to bring us in-house for 2 days. You can get your feet wet with a couple of these modules, and that will start to help out. I haven't said this anywhere on social media yet, but we do have our first version of our Mesh Mixer Masterclass manual available in our shop page, for the digital P&O workflows shop page. So if you're looking to just have a written document, step-by-step manual for a few devices, that is available in our shop right now. So that's a great place to start. Start to wrap your brain around kind of what this design looks like. Have a tool, a guide, a step-by-step process to guide you through some of those initial steps in Mesh Mixer, getting oriented in that software. That is a great resource right now that's available on our website. So, aside from all that, again, doing these in-house trainings is really where you're going to, build this relationship with us to have an ongoing, supportive training experience over the course of a year. It's not just those 2 very intense days. It definitely is a building and compounding effect over the year. So again, whatever you're looking to 3D print with low-end 3D printers, high-end 3D printers, we will come in and help you out with those printers and software to make sure that you're working on exactly what you want to work on. On a different level, we have a lot more requests for actually people here locally in Saratoga Springs, New York, for little one-off projects. Right now, we're working on a sign, actually, pretty cool sign for a local business. We're going to be printing that on our black belt 3D printer. So the black belt is a conveyor belt, really, really neat printer, can print continuously long prints. So either prints in succession or just very, very long prints with the support of a roller table after it. So that is a very, very cool machine that is kind of, opening up our minds to different ways of printing different things. So the evolution of Ascent Fab, getting into a lot of other industries now, getting into some silicone 3D printing, getting into this more industrial style FDM 3D printing. We can do reverse engineering of different parts. So for instance, this was a kind of fun, project to work on the other day. A woman locally called me up and said, "Hey, I've got this part that was in my kitchen drawer, and my granddaughter broke it when she pushed it in too forcefully. She feels bad about it, but could you help us fix this part?" I said, "Sure, come on in. We can take a look at the other side part that you have. I'll take some measurements of that and then recreate that design in Fusion 360." So I was able to do that within a half hour. That was a pretty neat application where they came in, they dropped off the part. I said, "Come back in about 2.5 hours," and actually 2 hours. I think I told them 2 hours, and I'll have the design finished in about a half hour, and we should have 2 of them printed in an hour to an hour and a half. And that's exactly what happened. Used one of the artillery Sidewinder X2 printers to print with a 0.4 nozzle for this very small, intricate part, printed out of PLA. And it worked very, very well. She was very thankful. And, that was a great instance of, kind of rapid prototyping, 3D printing being put to use, right? This is production level, equipment and software and materials and knowledge. It's the know-how in how to use all these things to get to a functional part. So, when you're looking at 3D printing, it's not just prototyping, it's not just one-off custom things. This truly is for production style, status printing. Again, utilizing all those different steps to get there, the reverse engineering or just very thoughtful design work can get you towards a 3D printed part that is very, very useful, and in your everyday life. Another fun project that we do for ourselves every single day is we make out these Ascent Fab logo coasters. So the logo coaster here prints out in about 2 hours out of TPU, and we print it with a blue color and a yellow color, top and bottom. We mix it up a little bit just to have that cool, logo kind of come off the coaster. Shown that around to a few of the other bars and breweries around here, restaurants around town. And they've been pretty interested in that as well. We're doing one right now for one of the distilleries locally. So that's pretty neat and fun to work on. So we're working on a lot of cool new projects here locally. I am trying to get now a little bit of foot traffic in from Saratoga Springs downtown. I don't know if any of my listeners have ever been to Saratoga Springs or really know about kind of what our town is based around, but in the summertime, our population explodes. We have the horse race track. Saratoga Race Course is one of the most popular race courses in the country. There is the Travers Stakes, which happens after the Triple Crown, and they tend to call our race course the Graveyard of Champions because there's Triple Crown winners. If you're into horse racing, Triple Crown meaning there's 3 races that they win, and they come to Saratoga for the Travers, and most of them lose actually. So kind of an interesting health history and horses mantra here in Saratoga Springs. There's a lot of buzz going on right now in the downtown area. Again, if you're listening to this locally, thank you very much for listening. We are located at 480 Broadway in the lower level of this Collimer building. If you see the Savory Pantry and Saratoga Olive Oil right next to each other, go through that door right in between them. I have a sign right outside on the street that we'd love to have you in. Stop by anytime. We're now setting up our space. We've just moved into another office directly on the other side of the wall from us as well, doubling our space right now. So as we continue to add printers, we are now building this space into and probably one of the only brick and mortar 3D printing stores. Who has that right now? Maybe Matter Hackers in California. I know, I believe MakerBot had one in Boston, I want to say, or it was New York City or somewhere. I think it was Boston a few years ago, maybe back around 2016, 2017 time. Not many brick and mortar 3D printing stores that you can actually go into, buy a 3D printer, buy the hardware. We are a reseller for E3D, as well as print dry, so you can have your dry filament, and a number of different filament suppliers, namely ColorFab, PP Print, and a couple of other ones that are up and coming, Xteller being a newer one where we're starting to work with on a couple really cool recycled materials and kind of more bio-friendly materials there. So come in, walk in. We have the Artillery Sidewinder X2 for sale, $300 entry level. We're kind of locally here. We'll actually go in and install it, in your business or in your house even, for an extra $100 on top of that. We'll come in and get you printing within the first 2 hours. So kind of a really neat way, I think, to set up part of our business, showing off, first off, what's possible, right? That's part of 3D printing right now in general, is we got to show people what we can do with it. So having kind of a showroom aspect to what we're doing, as well as a walk-in 3D printing store, I think it's going to be really neat to have that kind of business, and to see how that's well received. So with Ascent Fab being this contract manufacturer within the prosthetics and orthotics field as a central fabricator, as well as outside the field in a number of different industries right now and growing rapidly, having the training side of things either virtually or in person, having the filament resale, go on ascentfab.com/shop. And then with the 3D printers as well, right? We serve a number of different 3D printer manufacturers. Artillery Sidewinder, already mentioned that a few times. Black Belt 3D, we're the North American distributor for Black Belt that comes out of Belgium. We do a lot of work with Filament Innovations out of Copley, Pennsylvania, and serve their machines as well, distribute their machines. So on the lower end, all the way up to the higher end, with filament printing, pellet printing, even with Filament Innovations, the Aries, we run the full gambit of FDM 3D printing. So Really look forward to hopefully working with more of you in terms of your 3D printing journey, whether you're in the prosthetics and orthotics industry or not. If you're local in Saratoga Springs and you want to come on down and check us out. We'd love to chat with you in terms of, getting you 3D printing something or, helping you actually with a part. So stay tuned as well. Later on in the year, we're getting into some chocolate 3D printing with Cocoa Press. Really, really cool and fun. Come on, we got to have some fun with this. Chocolate 3D printing. What's more fun than printing with chocolate? Gonna have one of the Cocoa Press DIY kit printers later on in the fall. So that'll be a pretty fun thing to get into. So wanted to end here with the tech tip of the week. Thank you for listening to this Fabrication Friday podcast, going over our print of the week, our carbon fiber polypropylene new material, all the way through kind of, where Ascent Fab is at right now, kind of what projects we're working on generally, and what we offer to the prosthetics and orthotics industry, as well as outside the industry as well. But yeah, getting into our tech tip of the week. It is focused around your Z offset or Z gap. This is crucial for a good first layer bed adhesion for that material. So what we mean by the Z offset or gap, you're basically looking at the distance between the nozzle and the bed. So depending on your printer, they might have kind of an automatic sequence to go about bed leveling and go about the Z offset gapping. They're all a little bit different, but the general idea is kind of the same, where you want to get that nozzle very, very close to the bed. Typically, we're putting a piece of paper underneath the nozzle, and you're kind of like feeling for the friction between the paper and the nozzle. So typically when we're doing this, after you have your bed leveled, again, there's a number of different ways different printers do that. You're looking for kind of this medium friction. Now, this is going to take some time to understand what medium friction really means. But basically, if you put the piece of paper underneath the nozzle and you're slowly, incrementally moving the nozzle closer to the bed, to the paper, and so get it to the point where it's just barely has some friction on the paper, and then go one or two touches down more to kind of some medium friction. If you go a couple clicks past that, you're going to get high friction. High friction would mean that your paper's not moving, and you might rip the paper from in between the nozzle and the bed. Get a little bit more Z-gap distance between that. You don't need it that close. You're probably going to ruin the nozzle. So go up a little bit to kind of medium friction for almost all printing materials except ColorFab's VarioSure. ColorFab's VarioSure is interesting because, again, it foams as it prints. So you actually want more light friction between the nozzle and the paper. This is going to give you a little bit more room for that material to foam. And depending on the size nozzle you're using, typically we don't like to print under 0.6. But really with a 1 millimeter nozzle or even larger, we go to 2.5 on the Filament Innovations machines. You want a little bit more room for that VarioSure to foam. And it will have great bed adhesion to almost every surface you're going to print on. So, really looking at that Z gap as your baseline indicator of trying to establish a good first print. When you print that first layer, if you run your finger over that layer line and it moves when you just kind of run it over lightly, then you're not close enough with that Z gap. Even if you had glue on the bed or some other adhesive on the bed, if you can move that little filament, that one layer of filament, then you're not close enough to the bed. Go back to your Z gapping. Make sure you can't move that first layer with your finger, just lightly passing your finger over it. So that's our tech tip of the week. Look for your Z offset as the starting point of a good print. If you want a little bit more help troubleshooting this, we can absolutely help you here at Ascent Fab. But thanks again, everyone, for listening to this Fabrication Friday. Happen on a Sunday. We'll get better at that, I promise. Next week's going to be really, really fun and interesting too. So definitely listen in next week as I sit down with the one of the founder and owners of LutraCAD, another foot orthotics software. So thanks for listening to this Fabrication Friday, and we'll see you next week. All right, have a good one.